Okay, welcome back to the Zoom session. Those of you who just arrived, be sure to sign in. Here's the link to sign in. Right now, I'm gonna begin with the announcements, a few announcements. So let's see, let's start. I'm gonna share screen number 2. Here you go. So I put quite a few things over here. Wait, you guys see my Canvas page? Yes? You see my Canvas page? Can anyone give me either thumbs up or say yes if you see my, I'm just worried if I shared the wrong one. Okay, see Canvas
Yeah.
page. Okay, good, good. So I put quite a few things in here. Number one, I just moved this Zoom link to the top of the activity 0. So if you look at under the activity 0, that's your Zoom link over here. I know last time people get confused, like, where is the Zoom? I was checking, I think some people checking in the Zoom, but I did not set up this Zoom here. The Zoom link is right here. So you can click over there to join. And then also because your school has the policy to ban cell phone from the classroom, we cannot really sign in using the QR code anymore. So someone suggested perhaps we can put the link on Canvas, which I did. So right here. So from now on, you can click the sign in form just right here on Canvas. And then it takes you to this one. So you can just sign in right away, put your name, class. I think this is Reseda, and then put the word of the day. And then you sign in and signing out later. Okay. So it's right there. And then another thing that I added is the activity number 5 right here. So underneath the resources section, this resource section, there's I put the Zoom session that the recording from last week. I don't know if you guys find it useful. I know some people don't like to watch recording because it's takes more time or whatever, right? So, but in case any of you find it useful, you want to re-listen to it, it's right here. So I may put what we discussed today over here, but we will see. I mean, right now only have what 1, 2, 3, 4, 8, 7, 10 people. So we're missing 7 people in here. So okay, and then last but not least, someone asked about the SOP assignment. It's over here. So there's this right here under the Canvas assignment. It's not yeah, it's not March 14th, it's March 21st, which is actually this Friday. So this March 21st is this Friday. Make sure you submit that one there. It's basically over here, the SOP spectrophotometer right here. So you just need to upload it as PDF. Only PDF file is accepted. Okay. So yeah, I think that's pretty much all the announcement I have. If you be sure to check out the dynamic timeline. Where's our dynamic timeline? Here's one. So this week we're gonna continue with the absorption spectrum, the dye. You're still gonna play with the dye. And you are going to first look at the absorption spectrum and then start moving into a standard curve on Friday. So can any of you give me an update of what you guys did in the lab? Where are you right now in the lab? Did you select? I know you get the regroup already. You got new groups, right? And then did you guys select the new die, like the unknown die?
Yeah. For my team, we selected the dye, then we used the spectral photometer to measure the thing, the absorption, and then we wrote that down on the table.
Okay, and then what? And then I say someone says we all went through our own die and wrote down the number on spectrophotometer. What kind of number did you get? I guess like I'm trying to figure out how many numbers you get. Is it just one?
For we got we had the oh, Rebecca, do you want to say?
My group at least, we did 2, like, what's it called when you put more water in, like the dilutions, and then we did a measurement for every 20.
Okay, you did that one.
Yeah.
Did you use the okay? So I think everybody received an SOP that was made by other student before, right? Were you able to follow that, or it's just too confusing?
Mine was really good.
Oh, okay, okay. See, I mean the SOP were created by students, and some of them are good, some of them are less good. So hopefully when you guys turn in yours, I'm going to give your SOP to the student at Pierce, which is the one that's in the Saturday Sunday class. They're not gonna start this experiment until maybe like about 2 months from now, maybe like a month and a half from now, before they start that one. So once you submit yours, I should have about 10 to 17 of you, because I assume some people will not turn in that one. But then I just need at least like 7 or 8, so I can print it out and give it to them, and they will be the one that's looking at your SOP. So with that said, you don't have to put your name in the SOP, because as you submit your SOP on Canvas, I will know who you are, right? And I will give you the grade. And then if you put the name in the document, like in the like in your SOP, then your name will be attached there. So when I give it to someone else, they will know who made it, right? So the idea is I don't want people to like it should be anonymous whose SOP it is. So anyway, so yes, hopefully. So did you guys do the absorption scan? Did you do the absorption scan function, right? Instead of like instead of doing it one by one, right? Is it? Did you guys do that one, or? Yeah, so there's a there's a absorption scan function which allow you to do that. And were you able to get the dilution on point? So get the what is that called, to get the OD between what 0.9 to 1.0? Yes, anybody? Or are you still working on it? Okay, I see Joseph's. Okay, what about other people? Were you able to get the range, or are you still working on that? Still working on that. 3 times. Okay. Okay, some people get that one. Edward to get that one. Okay. Okay. So so what my plan today is actually to go through serial dilution, and then going through the gel electrophoresis theoretical. That's sort of the plan for today. So before that, is there any particular question? Did you guys go to the dilution at all? Did you go through the calculation for dilution on, I think, on Wednesday and Friday, or no? No. Yes. No. Get to okay. Yes. Okay. So oh, that's great then. So we don't have to do too much today, or we don't have to do too much. Don't have to spend too much time to talk about it. But nevertheless, okay, let's do some check today. Let's do some dilution conversation. So let's see. I'm gonna share my where I'm writing. Script number 4. There you go. Okay, you can see my notepad, right? Okay, yes. Okay, so let's just do some interactive thing. Let me pull up my chat right here. Okay. So let's say you have this original tubes. Just doing some check over here, right? Here's my original tubes, right? And then I took maybe 2 mil from here to put into this new one that has already 8 mil of water. Okay, so let's just call this one A. Okay, and then from here I took 1 mil to make B, which already have 9 ml of water. Okay, let's just make it simple like that. What would be the dilution of A and B? What about the total dilution in A and B? So what do I mean by this? When I ask this dilution, it means if I ask what's the dilution in A, it means it's the dilution of A in relation to the original, right here, the original, right? And then the dilution in B is the dilution B in relative to A, okay? Whereas the total dilution is always in relation to the original, okay? So if I ask what's the total dilution of B, it means you have to also take account of dilution from the original to A and then A to B, okay? So now, can anybody, okay, let me just give you maybe 5 minutes to work on this. But before that, if you feel, okay, if you feel you're confident you can do this, can you give me a thumbs up if you think you can do this? Or you want to this, if you feel confident, just give me a thumbs up. If not, we probably gonna go over a little bit, you know, first. So not every, you want me to go over this? Yes, no, maybe first, maybe go over it. Yeah. Okay, let's just do this one first. All right. So let's just discuss the dilution here. Okay. So going from original to A, you take 2 ml, right? So this 2 ml, I'm just gonna write it here. Okay. Dilution question. From original to A. Okay, so you take 2 ml and then you add 8 ml of water, right? That water is a solvent. So if you take 2 ml of your dye, adding 8 ml of water, the question is how much dilution did you actually perform? What's the dilution factor? We call that actually dilution factor for this type of dilution. Well, so this is 2 ml of dye plus 8 ml of water. It means the total volume total is 10 ml, right? Because you add 2 ml of dye plus 8 ml of your water. So it means the total is 10, which means now your dye over here, originally you only have in the volume of 2 ml, now you spread them into 10 ml. It's kind of, again, like if you think about perfume, right? If you spray one squeeze of your perfume bottle, put it in that small container, let's say just 2 milliliter of volume, the smell must be very strong, right? But if you put it in the larger container, maybe, you know, in this case, 5 times larger, which is 10 ml, the total volume, then the smell will be less strong, right? But the question is how much less, right? So that's the question, right? The way you do that is this, right? You have to calculate the total volume, which is 10, and you need to know how much of the original solution you use to make that 10 ml, which is 2. It means the dilution in this will be 2 to 10. Okay, that would be the dilution from original to A. Now, of course, if I leave it like this, mathematically, this is correct, but I'm sure your math teacher will not like it, you know. This is not the simplest what's that called factor, right? So you have to divide both the numerator and denominator by 2, and you end up with 1/5, right? 2 divided by 2 is 1, 10 divided by 2 is 5. So the dilution for A is what we call 1 to 5 dilution. Okay. Now, if people ask you what is the dilution factor for this, so the DF, right, from original to A, the dilution factor would be this one right here, which is 5. So the dilution factor is 5. It means you diluted 5 times in terms of the strength. The strength get reduced by 5. So if your, let's say if your original OD is, I don't know, 1.0, and you dilute it 1 to 5 like this, you can expect the OD become 0.2 or something like that, right? So because you dilute that one 5 times, or by a factor of 5, right? So let's do the next one, which is a B right here, right? So the dilution from A to B, right? You took 1 ml of the dye from A, right? Plus 9 ml of water. Again, the total volume here is 10 ml, right? So now you take this 1 ml and 10 ml, so therefore the dilution is one of the dye into a total volume of 10, so it's 1 to 10. And you can actually say that the dilution factor from A to B is 10. The dilution factor is 10 in that case. So you can say, if I ask you what the dilution is in from original to A, is this 1 to 5, right here. But then the dilution factor from A to B is 1 to 10. Okay. Is that clear so far? Give me a thumbs up if it's clear. Yeah, this one will be on your, I hope you guys are, I know I cannot see you. This is why I don't really like Zoom. I can't see you, right? I don't know whether you're actually taking notes diligently or you're just losing watching anime or something. I don't know. Right. So but make sure you can take notes, okay? Because you can best believe you'll see this question in the final. Okay. What if you were to go on an extra one? What if you were to go on an extra? Oh, you mean you want to from B to C, for example, like another dilution from B to C, C to D, something like that? Yes. Someone asking a question. Okay, we're gonna have another example right after this, but for this one, I just trying to give you an example of what we are looking for. But yes, we will do some problem a little bit later. Okay, so now let's talk about the total dilution. Okay, so the total dilution from original to A is essentially the same, which is 1 to 5, because you only did one dilution from original to A. So the total dilution is that one dilution you did, right? But when I start asking the total dilution for B, right here, this one right here, then you have to account this dilution from original to A as well as the A to B. So how do you do that? Well, the way you do that is simply you multiply the two together. So if you have 8, so what is it? From dilution from original to A, you multiply with dilution from A to B, right? So that would be our total dilution. Okay, and the dilution from original to A is 1 to 5. And then the dilution from A to B is 1 to 10. In this case, 1 multiplied by 1 is 1. 5 multiplied by 10 is 50. So in this case, the total dilution of B, if you account from the total from the original, is 1 to 50. Okay. So which again, from original to A is 1 to 5, from A to B is 1 to 10, so the total will be 1 to 50. Now, if the question asks you about the dilution factor, for example, the total DF for this, it will be 5, and the total for that will be 50, right? The total dilution. Remember, the total dilution is essentially just you flip that, right? The denominator divided by the numerator. Okay. Any questions so far? Are you ready for a problem set now? Ready for problem set? Yes. Yes, let's do it. Okay, let's do it. I know everybody's like cricket, but we'll march on. Let's see. So here, let me give black ink. Okay, so let's just do this. Here's the problem. Let's say here's the original, and then I'm taking 5 ml and put it with plus 15 ml of water, and then from there I take 5 ml plus 5 ml of water. You know what? Let's yeah, okay. And then last but not least, you do 5 ml plus 45 ml of water. You guys want one more? Okay, why don't you do one more? Okay, last one, maybe 5 ml plus, let's just give you the easy one, 5 ml of, okay. Now let's just call this A, B, C, D. This is original, okay. So can you give me the total dilution factor, the total DF for A, B, C, D? Remember, this is the dilution factor, which means you have to flip that the denominator to be on the top. Okay, do it. Okay, let's maybe you know what? Let's do this. Okay, I'm gonna break you into a group right now, and so you guys can chat on your own. Let me take a breakout room. I'm gonna assign how many people is 1, 2, 3, 4, 5, 6. Okay, I'm gonna assign 3 breakout room, and I'm gonna assign automatically. Here you go. Okay, I'm gonna open it up so you can go there and start working on this with your group. And I'm gonna join from time to time. Okay. And see who's actually here and who's actually logged in and snoozing. Okay. And I send it again. Okay, how do I send it again? I don't know how to sign it again, Lisa. Yeah, maybe you can. There's a. It won't let you join. Huh? Let's see if I can send you there. Put in waiting room. Oh no. Where is that? I don't know how to put you there. You know, there's the. Okay, you see my. Do you see my Zoom thingy? My Zoom. Right? Yes, you see it. Yes, so it's usually under the more right here, and there's this breakout room, and you click it, it should come out something like this, and then you can choose to join. You know, I think yours is in here. Just join there. And you, yeah, yay. Yeah, I think everybody's back. So let's see again. We can discuss this. Okay, share screen number. Okay, there you go. Okay, so anybody can tell me the number they get for total dilution factor for A? Anybody want to tell me? Check the thing. Open up my chat. Okay. Okay. 2 people says 4. Total dilution is 4. Okay, so let me put another one dilution factor here, the one that's not total, right? So I assume this one's also 4. Okay. What about the total dilution for B? Anybody get a number there? For B? The total dilution for B, someone says 8. Okay, anybody else get a number there? Nobody else get a number. Okay, just 8. Okay, and then C, anybody get a number, total dilution for C? Okay, someone says 80. Okay.
We got something else.
You got something else? Okay, okay. We'll go over it. For D, so someone says 10. Okay,
I lied.
okay. And then total dilution for D is 160. Okay. So let's see how we actually get this. All right. So let's take a look at A first. Okay. For this A. Okay. For A, you take 5 mil from original to A. You take 5 mil into 5 mil of original into a total of what, 20 mil, right? 5 mil plus 15 mil. 5 plus 15 is 20 mil of total of volume of A, right? That gives you 1 to 4, right? So it means you dilute it by a factor of 4, right? And therefore, the dilution factor, by extension, your dilution factor equal to 4. Okay. Now, for total dilution factor, because you only have one dilution, your total dilution factor is the same as your dilution factor, right? So that's why you have 4 over here and 4 over there. Okay, I think everybody get that one. That's good. So now, how do you calculate the total dilution factor from A to B, this total dilution factor of B? Well, in order to do so, you need to calculate the dilution from A to B first, because remember, by the time you get into B, you've gone through two dilution event, right? From original to A and from A to B. You already calculated from original to A, which is dilution factor of 4. Now you just need to calculate from A to B, right? So how do you calculate from A to B? Let's just put the wall over here. From A to B, you take what is that? The 5 mil of A, 5 mil of A divided by the total of 5 plus 5 right here. 5 mil of A plus 5 mil of water, so total 10 mil of volume B, and therefore it's gonna be 5 over 10, which is essentially 1 to 2, right? I just simplify it. Just like if you look at the very first one here from original to A, it's technically 5 over 20, but we simplify into 1 over 4, right? Same thing that here from A to B is technically 5 over 10, but we simplify this into 1 to 2. Okay, so technically the dilution factor from A to B alone, if you just look at A to B alone, is 2, right? It's just this one, 2. That's the dilution factor right there, right? So, but then remember, the total dilution factor is you simply multiply them together. So 4 times 2, so 4 times 2, making 8, right? That's basically where the number 8 come from. Okay, is that clear for now? Or P? Yes, no? Yes, no, okay. So now how do we calculate C then? What is the total dilution of C? Well, again, you do the same thing. So from remember for C, you've gone through 3 dilution events from original to A, from A to B, which both of you already calculate. Now the only thing left is just from B to C. That's the only thing left you need to do. So again, you write it from B to C. What do you have right here? So from B, you take 5 mil of B divided by a total volume of what? 5 mil plus, this one here, 5 mil plus 45 mil is 50 mil of volume B, of volume C in this case, right? So you have a total of 5/50 or 1 to 10. Remember, this is 5/50, this is 5/50, which is essentially equal to 1 to 10, right? So the dilution factor for just B to C, the dilution factor just for B to C is actually 10. But this, if you put it here, this is 10, right? So if you have to calculate the total dilution factor of C, then you have to account for the dilution factor of this, from original to A, and then from A to B, and from B to C. So you can actually multiply all of them together, for 4 times 2 times 10, which then turn out to be 80 right here, right? Or you can alternatively, you can just take this one right here, this 8 right here. This is the total dilution up to B, right? And then you just multiply that with the C, which is 10, and that gives you your 80, right? I think I should probably change this instead of this one 4, right? To make it more universal, right? Make it easier for you to see. So again, from original to B, you already calculated, which is this one 8 over here. So now we just need to account for the dilution from B to C, which is 10, and that gives you 80 over there. Okay. Now let's just do the last one, which is total dilution of D. Oh, someone forget to swap it, multiply. Yes. So for total dilution of D, you have 4 dilution events. Original to A to B, B to C, and C to D. You already calculated all the 3 previous dilution, which is giving you that 80 total dilution factor. So you just need to calculate the last one, which is the C to D. How do you calculate C to D? It's very simple. You take 5 mil of C divided by 5 plus 5, which is 10 mil of VD, and that will give you 1 to 2. Right. So again, from the 5 divided by 10, which is 1 to 2. Right here. So therefore, the dilution factor from C to D alone is 2. The dilution factor is 2 right here. And therefore, to calculate the total dilution factor of D, you just multiply 2 by the original to C that you've calculated before. 80 times 2 is 160. And that's why this one is 160. Is that cool? Do we understand that now? Very clear, crystal clear, right? Easy peasy. Yeah, what you've seen over here is what we call serial dilution, because you're diluting, you're using the previous dilution to do the current dilution, right? So you use, so after you dilute original to make A, you use that A to make a B, and then you use B to make C, you use C to make a D. That's why it's called serial dilution. And your ability to calculate the serial dilution is very, very crucial to work in the lab. You have to be able to do this very easily. Okay, this is something that a lot of students do not have this struggle with this. So I just want to make sure that you know how to do this. Okay. So yeah. So what's the point of us doing this? Right? Why are we doing this, right? Well, the reason why we are doing this is because you know, if I ever ask you later on, let's say you've done after, you know, let's say for your dye experiment, right? You have to do this dilution, and then when you take the original, you put it in the spectrophotometer, the OD is way more than 1, right? More than 1.0. Then you dilute it to make A. You put it again, oh, still more than 1.0. You do it again, you do dilution, get a B, right? And then the B, you put B, and still more than 1.0. You did, you make C, and finally you measure your C, and then, oh yes, I get my OD to be, I don't know, 0.9 or something like that, right? Let's pretend that the OD of this one here is 0.9, let's say, right? Now, if I ask you, then what is the theoretical optical density for B, for A, and for the original then, right? Of course, you can't really get the OD of B or the original directly by measuring it in the spectrophotometer, because it gives you the number that's probably not accurate. Remember, it's outside of the linear range of the machine, right? So if I ask you what's the theoretical OD for the original solution, well, you have to, how would you approach that? Well, there's actually a formula for dilution, and that formula is this very famous formula, and that I'm going to give it to you right now, and that is called the C1V1 equal to C2V2. Have you guys seen this equation before? Give me a thumbs up if you have seen it. Do you want to see it? Okay, only 3 people see it. Okay, 4. So if you have taken some sort of chemistry, yeah, this is for stock solution. That's correct. Yeah, it's kind of like for the stock solution, right? But it's also applicable for other stuff, for dyes, for DNA, for protein concentration. It applies for a lot of different things. Okay, so in principle, you can use the same one. I know, like, if you take chemistry, your professor will like to give you M1V1 equal to M2V2, right? That's just for chemists. Chemists love their molarity. And the reason why they do that is because in the chemistry class, they only give you, most likely they give you molarity as the unit of concentration. But for us, we like to use the letter C, because this C can be used for almost any unit of concentration or cell density, if you will, right? So so like the C1 V1, the C here, well, 1 is the initial, 2 is the final. Okay, so the C is the concentration. So if you're working with dye, this one is concentration. If you work with bacterial culture, this can be your cell density. So you can also actually use this equation to calculate your cell density as well, okay? Whereas the V is the volume, okay? So how do we apply this equation, right? Well, remember, if our original question is, let's pretend your OD of C, after you dilute it up to C, you measure the OD, it turns out to be 0.9. Now I will ask you, what's the theoretical optical density for the original, right? So how would you do that? Well, this is where we go for here. So the way you approach this is the following. Well, you have your C1 V1 equal to C2 V2. So the first thing, the best way to approach this is always write what you know, right? Always start with what you know, and then try to write what you need to know, what you have and where you what do you wanna have, right? So in this case, your what do you have here? You have your OD of C. So the OD of C, let me just write it down here. The OD of C is 0.9. That's what you know. And then what else? You know the dilution factor also, the total dilution factor, dF from original to a C, which is 1 to 80. What does this dilution factor represent, right? The dilution factor represent that it represents the following. It means the C, the concentration of C that you have right there is equivalent to the solution if you take one part of the original to make 80 mil or 80 part of C, right? So remember the total dilution factor, it accounts for original to A to B, B to C, right? So of course you I mean you did not really make 80 mil or something like that, right? Or right, you make a small volume here, only 20 mil of this and only 10 mil of that, right? And only 50 mil of this. You didn't really make the total of 80 mil or something like that, or 400 mil or something like that, right? But this is this ratio basically show you the relation between the original and the C. So 1 to 80 total dilution factor means in order to get the same concentration, you have to take one part. It can be mil, it can be microliter, it can be whatever that part is. It can be one, you have to take one part of the original and you have to dilute it all the way to a total volume of 80 part. So if your part is, if each part is 1 mil, then you take 1 mil of original, dilute it up to 80 mil of C, the total, which is like, at 79 mil of water. If the one part equal to 2 mil, then you take 2 mil of the original, you dilute it up to 160 mil to make the C, right? So this the ratio is just part, whatever your part is. Well, if the simplest one is 1 part equal to 1 mil, it means you take 1 mil of original, you dilute it up to 80 mil to make your C. So that's basically what it is. And because of that, this can be a unit of volume. This ratio here can give you a sort of like a unit of volume there, right? So this one will be the volume of initial V1, and the second one here will be the final volume V2, right? What about this OD of C, this 0.9 here? That will be the final. C is your final, right? If you look at this one here, the C here is the final, right? So that will be your C2. So now you have C2, you have V1, you have V2. Now you just plug it in, C1, V1 equal to C2, V2. The C1 here is what you're looking for, the concentration or the theoretical OD of the original. That's a C1, right? The concentration of your original. Because remember, the OD is not necessarily unit of concentration, but remember from the Beers-Lambert law that we talked about last week, the Beers law, right? The concentration is proportional to the OD, the ABC formula. Remember that? So if you calculate the, if you know, and because of that equation, you can actually use the C1 V1 equal to C2 V2 to calculate your absorption or theoretical OD in a way. So again, this is C1 multiplied by V1. The V1 in this case is one part, or you can just say 1 mil if you assume one part equal to 1 mil. And then the C2 is your OD 0.9. Remember, OD doesn't have any unit, right? It's just arbitrary unit or AU. And the V2 is 80. And in this case, 80 mil, right? Should right erase it because yeah, there you go. 80 mil, something like that. And then you solve this equation, you divide both sides by 1 mil, therefore C1 is 8 times 9 is what, 72? Right? So you can see from here, the OD, this is your OD is 72, which again, this is theoretical OD, right? It's not the real OD because in real, you can't really measure and you can't really take that stock solution, put it in the spectrophotometer, and they spit out the number 72. It's just not possible because remember, it's outside of the linear range. There's no way you can calculate, or there's no way you can actually obtain the OD if you just put this directly to the spectrophotometer. However, with this C1 V1 ratio equation, you can actually calculate the theoretical OD. Now, again, why do I mention this as well? Because maybe in the real lab, you may be asked to do this, or maybe it's not OD. Maybe your C, you have, or maybe the original. Your original, the exact concentration, which is like, I don't know, maybe they give you some molarity of the original, and by using this calculation, you can figure out the concentration of C, right? Maybe if I ask you, let's say, for like let's say in the original, right? Maybe if I tell you, in order for us to make the original, we dilute 0.1 gram of the powder, the dye, in 100 ml of water, so making a total of essentially 0.1%, right? So by doing this dilution and having the dilution factor, you actually can calculate the concentration of C here, right? You can actually calculate the concentration of C just by using the C1 V1 equal to C2 P2. You just divide that 0.1% by the total dilution factor, which is 80, and then you get the concentration of the C, right? Yeah, so that's quite heavy. Any question about that? I think the good thing about this being recorded is now you get a practice, and then if you want to listen to it again, you can just open up the recording and and read it and listen to it again. Okay, is that cool so far? Yes. Now let's see. Okay. Well, I do not think we can get to the gel electrophoresis. I don't think that's wait. Yeah, I don't think that is possible because let's see. But I'm trying to find out. Okay, never mind. Okay, so instead, maybe I can talk about gel electrophoresis next time, but I'm gonna talk about standard curve for now. Okay, standard curve. What is a standard curve and why do we need that, right? The standard curve, people usually make standard curve to show the relation between what is that called, between the concentration and between the two things. Basically, you want to show the relation between the two things. In this case, for us, we want to show the relation between the OD and the concentration, that Beers-Lambert law, right? Essentially, to build that standard curve, you want to create something like this, where you want to graph where the concentration of dye is in the x-axis, and that the OD, the absorption, is in the y-axis, something like that, right? You want to create so that when you have 0 concentration of dye, your absorption should be also 0, right? Oh, by the way, just quick question. Did you guys talk about blank in the lab? Did Dr. Lily tell you about blank? Yes, no, maybe. Anybody? No, you didn't. Okay. So when you use your spectrophotometer, did you blank your spectrophotometer first?
Yes.
Yes. Okay, I like that. Yes. Yes. So what is blank then? What do you use for blank?
For the like zeroing it, we just used like a milliliter of water and ran it.
That's right. So that's what we call blank. So basically, blank is meant to tell the machine that, hey, this is your zero. This one has nothing more except water. It has nothing else except the water, right? So for if you try to use spectrophotometer for bacteria measuring bacterial density, your blank should be, the same as because you're measuring cell density, you want to have all the media there except without the cell. So later on, when you use spectrophotometer to measure cell density, your blank should be your fresh media, the sterile media. That would be your blank. But for you, for the dye activity, your blank in this case is just water. And again, essentially, the blank is there to tell the machine that this is your baseline, this is your zero. Okay. Now, if you put just the water, in this case blank, your absorption should be zero, which is down here, right? But as you increase the concentration of your dye, the absorption should increase. Remember that we talk about the what is that called, the linear range, right? It should have that linear correlation, something like that, right? Now, what's the purpose of this? Well, the purpose of this is if I give you an unknown solution with the same solution with unknown concentration, and you measure it after you dilute it, you measure it and you get the absorption value. Let's say the absorption is here, whatever this value here, maybe 0.7 or something like that. Then you can plug it into this graph and you can quickly figure out the concentration, right, from the standard curve. Right. Once you've built that standard curve, you can quickly find out the concentration once you know the absorption. And this is why I want you to learn how to build your standard curve. Quick question: are we done at 5 or 5.5? Anybody remember? But remember. No. Oh, 5:05. So I'm already 7 minutes over time then. Okay then. Well, in that case, yeah, I think I'm gonna stop here for now, and I'll see you guys maybe tomorrow, maybe not. I may not be there, but yeah. So otherwise, have fun. Don't forget to sign out. Okay.